everyone, and welcome to the Foundry by Forge College. I am absolutely thrilled you're tuning in for today's explainer, Synthesizing PoH Effects on Network Efficiency. Now, if you were with us for our last lesson, quantifying PoH's impact on transaction speed, you know we got our hands pretty dirty. We were deep in the weeds measuring raw data, like how proof of history tick cadence physically affects transaction speed. But here's the thing. Numbers alone, they don't build systems. So today, we are crossing a massive bridge. We're going to take those raw measurements and translate them into actionable, high-level conclusions about network efficiency. Basically, we're turning abstract metrics into a rock-solid engineering blueprint. And trust me, it is super satisfying once you see it all click together. So, here's our game plan for today. We'll kick things off with a simple assembly line analogy, then dive into the 4 key trade-offs you'll inevitably face. After that, we'll apply it all to a real-world payment flow and wrap up by learning how to write an actual synthesis memo. Let's get to it. All right, Section 1, the assembly line analogy. Now, you might be wondering, what do we actually mean by synthesis? Well, to really grasp this, I want you to imagine the blockchain as a highly coordinated, minimalist factory floor. Synthesis is simply taking isolated observations from that floor, like, say, checking how fast a single conveyor belt is moving, and figuring out if the entire factory is humming along profitably or if, half the workers are currently on fire. It's how we connect the dots, so we know exactly what to prioritize during a real-world integration. Okay, let's make this super concrete and map our technical terms directly to physical factory parts. Think of PoH tick frequency as the physical grooves on a moving conveyor belt. It's the spacing between the items. The validators? They're our quality inspectors, standing right next to the belt. Now, if you increase the tick frequency, you're bringing those grooves closer together. That speeds up the line, which is great for lowering latency, but it means your inspectors have to work furiously, drastically increasing CPU and I/O pressure. Throughput is just your items per minute. Latency is the time from dropping an item on the belt to it passing inspection. And ledger density, that's just how tightly we're packing all the finished goods into our storage bins. Which brings us to Section 2, the 4 key trade-offs. Any factory manager will tell you you absolutely cannot just crank every single dial to maximum without breaking something. And that perfectly illustrates our first major trade-off, tick frequency versus validator load. Like we just talked about, if we turn up the tick frequency, we get way more checkpoints. Customers love this. Their transactions confirm faster, and median latency drops. But the direct consequence? Our quality gate inspectors are sweating. Validators face significantly higher CPU and I/O pressure because they have to verify more signatures and do a lot more writing to the disk. Next up, we have timestamp fidelity versus ledger size. If we use richer, incredibly dense timestamps, we get this beautiful, precise forensic ordering. It's like slapping a highly detailed routing label on every single box on the line. But the catch is that packing our storage bins becomes an absolute nightmare. Ledger growth accelerates drastically. That means you're buying a ton more hard drives, and any historical re-indexing becomes way more expensive. Now, let's look at the tension between throughput headroom and tail latency. Pushing the system for maximum throughput sounds awesome on paper, right? Like we're using every ounce of our factory's capacity. But in reality, doing that usually causes a massive traffic jam. Queuing delays start to pop up, which completely ruins the experience for the unlucky items stuck at the back of the line. It drastically degrades the 95th percentile. Basically, your worst-case user experience goes right down the drain. Finally, there's historical data retention versus node diversity. Look, keeping massive, dense historical logs is fantastic if you need to debug or do a perfect replay of past events. But holding on to all that data makes running an archival node ridiculously expensive. And if it costs too much to play the game, smaller validators are going to drop out. Suddenly, you're centralizing trust among just a few wealthy factory owners, which goes against the whole ethos of a decentralized network. All right, Section 3, a real-world payment flow. Let's step away from the theory for a second and actually put on our factory manager hats. Imagine you are building a payment app. Your absolute top priority is lightning-fast confirmations for millions of people who are panic buying their morning coffee. You need incredibly low latency, but obviously you can't blow up the network to pull it off. So how do you balance that load? Let's look at the data. Looking at our lab measurements, we can see 3 very distinct scenarios. If we just bump up the tick rate by 25%, we hit our latency goals for the app, and our validator CPU utilization only goes up to a moderate, completely acceptable level. Perfect. But look at that third scenario. If we get greedy and crank the tick rate up by 50%, we are literally melting our servers for almost 0 extra latency benefit. It is a textbook example of diminishing returns leading to massive operational waste. Moving on to Section 4, writing your synthesis memo. Here is the most crucial point. How do you actually communicate all these brilliant findings to your team? You've got to take these insights out of your head and put them into a structured synthesis memo that guides your engineering and integration teams. Let's walk through a solid 5-step procedure to do exactly that. This is how you turn raw factory observations into a highly actionable blueprint. Step 1, assemble the facts. We don't guess here, we document exactly what happened during our test runs. You want to state clearly, hey, a 25% tick increase reduced median latency by exactly X milliseconds, while CPU load went up by exactly Y%. It grounds the entire conversation in reality. Step 2, map those facts to your priorities. For our coffee payment app, latency is the main goal, so tick frequency is our primary lever. But we also have to acknowledge the secondary costs, like the increased ledger density. You got to set some hard boundaries here, saying something like, we'll improve latency, but only up to the point where validator's CPU stays safely below our 70% threshold. Step 3, state the trade-offs explicitly. Seriously, don't hide the downsides. Write precise statements linking your measurements to the real-world consequences. Tell the team, this change is going to increase operational costs for archival nodes. But then, and this is key, offer smart mitigations. Maybe suggest slowing down the tick pacing during the network's off-peak hours to save on resources. Step 4, produce your memo outline. This needs to be concise and totally predictable. Start with an executive summary, lay out your measured evidence, clearly state your recommended integration priorities, highlight any risks, and wrap it all up with next steps. Keep the whole thing heavily focused on operational impact. And finally, Step 5. Validate with checkpoints. A memo is completely useless if you can't test it out. You need to define exactly what success looks like in a staging environment. Give the integration team very clear, testable acceptance criteria, like making sure the 95th percentile tail latency stays under a strict limit, or confirming that node replay times don't suddenly regress. You're basically giving them a safe sandbox to test your theories in. Which brings us to a quote that brilliantly captures our main takeaway for today. Decision makers seldom act on raw numbers alone. Your synthesis frames numbers as choices. Raw data is just noise to a decision maker or a lead architect. Your real superpower as an engineer is translating that cold data into clear, strategic choices. You frame the numbers so the team knows exactly what they're sacrificing to get exactly what they want. So, that leaves us with one final question. Are you ready to take these operational choices and turn them into actual component-level integration tests? Because that is exactly what comes next. I highly encourage you to visit forge.college to dive deeper into the subject and explore our full suite of Web3 courses. There's so much more to learn, and mastering these advanced Solana concepts is really just the beginning. Thank you so much for joining me on this explainer, and I'll catch you in the next one.